So in today's lecture, we are going to study the reduction of order method, which cover section 4.2 from the textbook. Actually, here the objectives of our lecture, and let us do some revision about what we studied in the previous 2 or 3 lectures. If you remember that if I have this non-homogeneous and linear differential equation of higher order with constant coefficients, that mean here those coefficients a0, a1, and so on, and an minus 1, and an, all those are numbers. Okay, do you remember how we can solve this differential equation? If you remember in the previous lecture, we said first step is to find the general solution YC for the homogeneous equation, the corresponding homogeneous equation, and we call this solution complementary solution for the associated homogeneous equation or corresponding homogeneous equation by taking the right hand side to be 0. Then I'm going to find particular solution for the given non-homogeneous equation. How to find this YB, the particular solution for the non-homogeneous differential equation? Maybe by guessing. Or if my Gx, one of simple functions, which we studied in the previous lecture as a polynomial, exponential function, sine or cosine, I can use the previous method to determine the value of, or to determine the function YB, the particular solution. We call this method the annihilator method. Then the general solution for this differential equation is given by the summation between YB and YC. Okay, we solved maybe 3 problems depending on this method. Now I have 2 problems or two issues. If my differential equation in this formula, notice now that the coefficients here, those aren't constants, but those are functions. So you can't at all find the complementary solution. If you remember, we found the complementary solution using the auxiliary technique. But now if those aren't constants but are functions, you can't use this. So I can't find YC. And also, so here the first problem, if those coefficients aren't constant. So now if I ask anyone of you how to solve this equation, with those coefficients aren't constants. So you can't use the auxiliary technique, because if you try to use the auxiliary technique, so here you have m squared minus x m power 1 plus 1 equals 0. So for me, I can't determine the value of m because I have the unknowns x here. So I can't use the auxiliary technique. So one difficulty for me, which I can't solve, depending all the previous lectures, I can't solve this differential equation. Maybe in today's lecture we can deal with it and we can find the solution. But depending on all the previous lectures, we can't find the solution of this differential equation. Also, the second problem here, if the gx here, the right hand side, isn't simple function. What I mean by simple function, it's a polynomial, it's a sine, it's an exponential function, or one of those products, because I can find the annihilator of all those. Unfortunately, if the g isn't one of them, so you can't use the annihilator technique. So if my gx, it is cosec x, you can't use the annihilator technique. So depending on all the previous lectures, we can't solve this differential equation. Maybe we can do that today or in the coming lecture. Okay, so the 2 difficulties for me, which I'm going to deal with them today, that first one, if the coefficients here aren't constants, how to solve this equation. And also the second difficulty is if gx is a complicated function and I can't find, or instead of saying I can't no annihilator for it. No annihilator for this function. What should I do? We are going to solve those two problems, or we are going to learn two different methods. Those two different methods will help me to find the solution of this differential equation such that this one isn't constant and the dx is a function which no annihilator for it. Okay? Any question before I continue? Any question about also the previous lectures? No question. So let us continue now, and I'm going to explain here how to use the new method. How to use the new method. First of all, let me tell you that today lecture, we are going to learn one method which will help me to solve only second order differential equation. So in today's lecture, only second order. Notice in the previous lectures, you can solve fourth order, fifth order by writing the auxiliary equation. But today's lecture, which we are going to study in it, the reduction of order method, this reduction of order method will help me to solve only this equation. Look to the equation here. It's second order. Okay? Notice here the coefficients of y double prime is 1. Okay? So the reduction of order method will help me to solve this equation depending on this hint, if you have first solution for the given differential equation. So let me explain again. I have this differential equation with coefficients here to be 1, and the coefficient of y prime, it is function of x, no problem, and the coefficients of y also it's a function of x, and the right hand side is 0. So in this slide I need my gx to be 0, but my coefficients may be a functions, maybe some functions here. Okay, to solve this equation you need first of all to guess one solution y1. Professor, the guessing is very difficult and I can't find any solution by inspection. What should I do? Actually, to make the problem easier for the students, I'm going to give you the first solution. And you need to find the second solution, because notice here, your differential equation of second order, so you have two different independent particular solutions. I will repeat, because your differential equation of second order, that means you have two different independent solutions. I'm going to give one and you should find the second one. And after that, you can write the general solution or the complementary solution. So after giving you first solution, you will use this hint. The y, it is u times y1. The u, it's the new function, and y1 is the given solution, and the y, it is the general solution for the given homogeneous equation. So this substitution will help me to find the general solution for this differential equation. After doing some mathematical calculations, we can get that the second solution for the given non-homogeneous differential equation is given by this formula. So what I need to write in your cheat sheet, that if you have a differential equation similar to this, notice the right-hand side is 0. The coefficients here is a function of x, and the coefficients here is a function of x, and the coefficients of y double prime is only 1. And I give you one solution. And I will ask you to find the second solution, so you can write this one immediately. No need to use the hint, because if you try to use the hint here, and your equation is homogeneous here, notice. So after some calculations, you will find the second solution is given by this formula. So you can add this formula to your cheat sheet, and no need to use this hint if your equation of the right hand side is 0, so it's homogeneous. Okay, but actually I'm going to use this hint. I'm going to use this hint today if the equation isn't homogeneous. So I should use this hint. Okay, let us read the second solution, y2. It is y1, which I'm going to give you, times integral fraction. In your denominator you have here, in your denominator you have the squared of my function, which I'm going to give you, and in the numerator you have exponential of negative integral bx. Where is the bx? Is the coefficient of y prime. Okay, is it clear now? When can I use this relation and why I'm going to use it? I can use it if my equation is homogeneous and the coefficients of yw prime is 1, and don't care about the coefficients of y and y prime, the coefficients of y prime and y, because those can be function. Don't care about this. Okay, and what about of this hint? Theoretical concepts will find this solution depending on this hint. And actually, I must use this hint and this substitution if my right-hand side, it is a complex function or any function in gx. Let me give you one example and you will understand how to use this formula. So here I have this differential equation. For me, this equation is homogeneous, linear, second order, but unfortunately, the coefficients here isn't constant. So I can't solve this equation using the auxiliary technique. I can't. What should I do? The reduction of order method can help if you have one solution. So you can find the second solution depending on the formula. Let me go to black slide and do it together. So here my differential equation, and I need to find the general solution. Don't forget that the general solution for second order differential equation is given to be C1 times Y1 plus C2 times Y2, because the equation is homogeneous. Okay, where is Y1? This is my Y1. This is my Y1. How to find Y2? So this is the solution. Do you remember the rule of Y2? Let me write the rule of Y2 here. Y2 is given to be Y1 integral. My denominator, it is Y1 squared. The exponential of negative integral of bx dx. This is the rule which you need to add to your cheat sheet. Now, where is y1? The y1 is given. Where is the px? Can anyone help to determine the value of px? Where is your bx? Where is the bx? Do you want me to go back to the rules?
Is 1?
It's 1. Yusuf and Salma is speaking now. Actually,
1 over x, doctor.
1 over x. Who said 1 over x?
Abdurrahman, doctor.
Yes, Abdurrahman, great Abdurrahman. It must be 1 over x because, look, let me go back here to the rules. Notice here, if you need to use this formula, the y2, you need the coefficients of yw prime to be 1. So Abdurrahman suggests, Professor, before you start solving your problem, you must divide the equation by the coefficients of yw prime. So here, great Abdurrahman, divide by x. So I will get yw prime plus 1 over x, y prime equals 0 over x, which is 0. So as Abdurrahman said, now my px, it is 1 over x. This is my px. So let me write now the formula of or substitute in y2 equal the y1. Where is my y1? It is ln x. So here ln x integral of y1 squared, it is ln x all squared, times e to the negative integral of my bx, it is 1 over x dx. all dx. So equal ln x integral, my denominator, it is ln x squared. Here I have e to the negative. What about of integral integral 1 over x? It is ln x. I think all of you know it. Ln x, here dx. Equal, let me simplify this up. How to simplify the numerator? How to simplify the numerator? It is
negative as a power.
negative to the power, you are right. So can I write it 1 over x? Can I write it 1 over x? So here my numerator, the denominator, it is squared here. So it is e to the ln 1 over x. Am I right? Because x to the negative 1 will be taken down. Here dx. So I'm going to cancel out e with ln. So my y2, it is ln of x integral. Here my ln x squared. Up I have only 1 over x dx. How to find the value of this integral? How to integrate this function? Any help to find the integral?
We will assume that ln x is u.
Great. Let ln x equal u. That will give me dx over x equal du. Am I right here? So let me substitute now. Go back to the yellow. I'm sorry. So equal. Don't care about the function outside of the integral. So here integral. What about of 1 over x times dx? What about of those? Those are what? Those are what?
Y du.
Those are du. Dx over dx. So here du divided. Here ln x squared. So it is u squared. So equal. Do you remember this integral? It's famous integral. Du over u squared. It is what? And can anyone remember?
Minus 1 over u.
Minus 1 over u. Abdurrahman also?
Yes, doctor.
Great. So it is negative 1 over u. If you don't remember it, take u squared up to be negative 2, then add and subtract 1. So now let me go back to my u. So I have ln x bracket negative 1 over your u, it is ln x. So cancel out ln x with ln x. So your y2, it is only negative 1. So now I have y2 here and I have y1 here. So the general solution, it is c1y1 plus c2y2, which is given to be. So the y general solution, let me write here the word general, equal c1 ln x minus c2, because my y2 is only negative. Is it clear? Any question here? Let me go to this.
Doctor,
Yes. Yes.
when we integrated, why we didn't add C?
Why we didn't add C here? Because we are going to find second particular solution for our differential equation. But by the way, let me consider that the student add this C in the exam. Okay, so I'm going to use the red to write here a plus C. So here a plus C, a plus C. So here a plus C. Am I right? So here your y2, it is negative 1 plus C. I'm going to multiply my C2 inside it. Okay, so it will be C2 times negative 1, which is negative C2, plus C2 times C. Am I right, Mira, here?
Yes.
Now those are one constant and this are one constant. I'm going to add them together and I'm going to call them, so here minus plus C3. So you need this one and C3 second constant. So if you add, don't care, you will get correct answer. Okay. Other questions?
طب دكتور ليه بقى why didn't we بقى have C when we integrated the E in the numerator?
Here.
Yes.
Why we didn't add the C also here?
Yes.
And also, by the way, you will get the same thing. So if I add the c here, when I integrate this e to the c here, so also you will take e for the ln and e for the c. So it will be e ln times e to the power c with no plus here. Take e to the c outside of the integral. So you have e to the c is a new constant. Okay, so here your answer will multiply by constant, here by constant, and here by constant. So it will be negative c. So all of them, if you add them together, you will get a constant. So if you don't care, you will get the same answer. Okay, Abdurrahman?
Yes, thank you.
Welcome. Other students? So let me solve second example now. Please write your names. And let us solve the second example now. Maybe I'm going to choose some of you to help. I think it's easy. It isn't difficult today lecture. But by the way, this is the first step or first idea if my differential equation is homogeneous. So here I need you to use the reduction of order to solve this differential equation. What I mean by solve the differential equation, that means you need to find the general solution. And always, because your differential equation of second order, so your general solution must contain two constants. Okay? Now, let me look to my equation. Unfortunately, my equation with non-constant coefficients, so you can't use the auxiliary technique, and you must use the reduction order if you have one solution. Yes, great. Now I have first solution. So notice that if you have this equation, only this equation, without this solution, you can't use the reduction order method unless if you guess one solution for this differential equation. But for me, I'm not going to ask you to guess the solution. I will give you the first one. And you need to find the second solution. Then you will add them together to get the general solution. Let me go to black slide now and together do this problem. So now this is my differential equation, and together, please. Let me ask Abdulaziz here. Abdulaziz? Unfortunately, Abdulaziz isn't here. So let me ask Lubna. Yes,
Hi,
Lubna?
doctor. Hi.
Yeah. So now I'm going to solve this problem using the reduction of order. If you didn't write the rule of the reduction of order to find the second solution, I'm going to add it here. So y2, it is given to be y1 integral. My denominator, it is y1 squared, and my numerator, it is e to the negative integral of bx dx, okay? And here I have dx. So y1 is given here, so don't care about y1. Where is your bx now? Or should I do anything before that, Lumna?
We need to divide the equation by x squared first.
Great. So solution here, divide your equation by x squared, because if I need to use this rule, the theorem said I need the coefficients of y double prime to be 1. So I have. Yes, Lubna. What should I write now?
We're gonna have y double prime
Okay.
minus 3 over x y prime
3
plus
over
5
x.
over x squared y.
Great. X squared y equals 0.
Equals 0.
Now, where is your b? Where is your b?
Our p would be negative 3 over x.
Negative 3 over x, the coefficient of y double prime. Great. This is my bx. Let us apply the rule now. So now, here, my y2, it is. The y1, it is, where is my y1? It is x squared.
X squared cosine ln x.
Cosine ln x, okay.
And
Times
then
the
integration
integral, yes.
of e to the power of negative integral negative 3 over x.
Negative 3 over x, great, dx here. And your denominator?
X squared cosine ln x all squared.
Cosine ln x all squared times dx. Let us simplify this integral now.
In the numerator, we can take negative 3 out. and it's gonna negative and it's gonna cancel with the negative, so we're gonna have 3 integral 1 over x dx, which is gonna be
Yes, so let me write here
ln
x squared, just 1 minute, cosine ln x integral. You said that here up it will be what?
we can take the negative 3 out of the integral,
So it
so we're
will
gonna
be,
have 3 integration of 1 over x dx.
okay, integration of dx over x, okay. And here dx, and your denominator, I can write my denominator x to the power 4 cosine squared ln x. Can I do that? Okay, because you have squared here. What about of the integral up?
It's gonna be e to the power of 3 ln x.
So it is e to
Uh,
the what?
power of 3 ln x.
3 ln x, great. E 3 ln x. Here I have the x and my denominator the same, x to the power 4 cosine squared ln x. Okay, then
And then we're gonna take the 3 as a power to the x, so it's gonna
okay,
be 3 ln
great,
x to the power of 3. So the e
great.
and ln are gonna cancel out.
Great. So I'm sorry, it is cosine here. Cosine, then cosine of ln x. My angle, it is ln x. So here integral, you asked me to take the 3 up and cancel e with ln. So it will be x to the power 3 divided x to the power 4 cosine squared ln x. My angle now, it is ln x. I can cancel out this with the power 4. So I have the following: x squared cosine my angle ln x integral of dx up, and my denominator now, it is x cosine squared ln x. How to find this integral now?
We can let u equal to cosine squared ln x.
Okay, so repeat, Lubna.
Actually, no, u is equal to cosine ln x.
Yes, u equal cosine, cosine what?
Uh, Cosine of ln x.
Yeah. So I feel it's, this substitution isn't easy because you choose cosine and ln together.
Yeah, we can actually let it equal to ln x.
Yes. So let me choose the u equal ln x, ln of x. Okay. And by the way, I prefer to solve or to find any integral using 2 substitutions than using 1 complicated substitution. So if you choose u equal cosine ln, I think this substitution will be difficult. Okay. So now if you choose this, so that will give me du.
U is equal to dx over x.
Great, dx over x. Excellent.
So
So now
write the
equals,
equation.
yes, here x squared cosine ln x. Don't care about the function outside of your integral. So here, what should I write, Lemna?
We're gonna write 1 over cosine squared u.
1 over cosine squared u. Great. Don't forget du. Yes, du. Don't forget du. Yeah. And how to find this integral? Do you remember?
I'm trying to remember.
Yeah. So I have integral of 1 over cosine u. It is what? 1 over cosine. It is sec. Am I right?
Yes.
So it's sec squared u du. Do you remember the integral of sec squared?
It's tan.
Tan. It's tan.
Ln sec x plus tan x.
Just a minute. If it is tan, so the because the derivative of tan is what?
Sec squared x.
So derivative of tan 6 squared. So the integral of 6 squared, it is tan. Am I right?
Yes.
So here equal x squared cosine ln x tan what?
Tan
What?
u.
Tan u. And now go back to your u. So here x squared cosine ln x tan, instead of the u, you have ln x. This is your y2. So my general solution for the differential equation, it is C1y1, the given function, plus C2y2, which I found it now, this one. Is it clear? Any question?
Doctor,
Yes, Shannon.
when do we use the U substitution, the integration, and which function should we choose to be the U?
Yes. So your question about this specific problem or in general?
No, in general.
Yes. Actually, in general, if you have a product between two functions, okay, and one of them is similar to the derivative of second one. Notice now for my problem this one. I have 1 over x multiplied by 1 over cosine squared ln x. Am I right here by this writing? I notice that 1 over x is the derivative of the ln. I have a product first of all, and 1 over x, the first function, is the derivative of the ln. So I'm going to use this substitution. So the substitution generally can be used if you have a product between two functions such that derivative of one of them is similar to the second. Okay, Sha'lan?
Yes, Professor.
Yeah.
Thank you.
By the way, if any one of you forget how to use the substitutions to do the integrals, I think I advise you to go through the textbook of Calculus 2, and maybe you need only 2 hours to do some revision about those rules. Okay? Other questions?
I have a question. In
Yes.
the final solution for y2, can we simplify it even more by letting tan ln x equal to sine
Yes.
ln x over cosine
Yes.
ln x, and then
Yes, great, Lubna. So look, Lubna said, Professor, the tan x, it is sine over cosine. So I can cancel cosine with the denominator of cosine here. So it will be only x squared times sine ln x. You are right, Lubna. Great. Other questions? So let us go now. If no questions, let us go to the second idea of the reduction of order method. So don't forget that reduction of order method can help me to solve, first of all, homogeneous equation if I have the first solution, and also the reduction of order method can help me to solve non-homogeneous differential equation. But also I need one solution of the homogeneous equation. So in both cases, in which I'm going to use the reduction of order method, I need one solution for the homogeneous equation. If the question is to solve homogeneous one, and he give me the first solution, I'm going to use the rule of y2. But if the question asked me to solve non-homogeneous equation and he give me first solution of the homogeneous equation, I'm going to use the following substitution. So this substitution will help me to find the general solution for the non-homogeneous equation such that y1 is solution for the homogeneous equation. Don't forget that this reduction of order method is very important because it will help me to solve homogeneous or non-homogeneous differential equation with non-constant coefficients. So if your differential equation with non-constant coefficients, you need to use the reduction of order method. Okay? Did you get the idea? When can I use the reduction of order? First of all, if I have homogeneous with non-constant coefficients, but I have the first solution for this homogeneous, and I'm going to use the rule of y2. And also, now, if my differential equation is non-homogeneous, like equation number 1, and the coefficients aren't constant, so I can use the reduction of order, but I need one particular solution for the corresponding homogeneous equation. Is it clear? Take care that from this lecture, you have in exam 2 one question at least 15 marks, and in the final also one question at least also 15 marks. So this lecture is very important. By the way, I feel that you need to practice, and you need to solve a lot of problems. You need to do the problems which I did in my lecture by hand from A to Z. Please, understanding the lecture and reading the problems isn't enough at all. You can't get high marks in the exam and get high grade by the end of the semester if you didn't practice by hand and if you didn't do the problems from A to Z. And also for those students who need to be excellent in differential equation course, you must go through the textbook. You have to solve the problems or some problems from your textbook. At least try to do the solved problem in your textbook. And by the way, in each lecture, in the beginning, in the first slide, you will find the title of our lecture and the number of the section from your textbook. Okay, so please try to study everything and solve all the problems by hand. Now let me go to the coming one. You need to practice. I know that this semester is very fast, so every day you have to solve. Every day you have to do the problems. Now I'm going to solve this problem. This problem in exam 2 and in the final you will find similar to it. Be sure, similar to this problem you have one in exam 2 and one in exam in the final exam. Okay, let us together. Don't forget that the reduction of order method will help me to solve homogeneous and non-homogeneous equation if the coefficients are functions, not constants. Notice now the differential equation with non-constant coefficients. Okay, so I'm going to use the reduction of order. Now, which idea of the reduction? Because I have two ideas for the reduction of order. The first one, when my differential equation is homogeneous and he give me first solution, I'm going to find the second one depending on the rule. Second idea of the reduction of order method, if he asked me to solve non-homogeneous equation and he give me one solution, one particular solution for the homogeneous equation, so I'm going to use the hint, which is the substitution. Y, which is the general solution for the non-homogeneous, equal u times y1. Let me start solving this problem and we'll understand it more. So here the solution. Let us read the problem. Show that y equal x is a solution for this differential equation. Let me ask, I need Omar Salim. Omar here? Omar Salim? Yes, Omar. So now I give you first function y equal x. This is the first function. I need you to prove that this function is a solution for the differential equation. How to prove that y equal x, this one, is solution for this? Do you remember how to check a given function is solution for differential equation? Omar?
We can substitute every y equal x and
Yes,
find y dash and y double dash.
So let me, first of all, my y equal x, that will give me my first derivative is what? Yes, Omar?
Y dash equal 1
Yeah, and y double dash?
equal 0.
Yes, now go to your equation here, substitute. Yes, x cubed times, yes, continue, Omar.
0
0 plus 3x squared times
times 1 minus 3x times x.
great equal 0. Let me check if this is correct or no. This one will be cancelled. Now I have 3x squared here minus x times x, also x squared 3x squared equals 0. That will give me 0 equals 0. This one is correct. So yes, y equal x is the solution, is one solution for this homogeneous equation. Okay, thank you, Omar. Now the question is the second one. So this is the first question. Actually, in the exam, to solve this question, you will get 3 marks. Okay. Then to solve second question, let me use the yellow now. To solve the second question, you will receive, if you did correctly, you will receive 12 marks. So find the general solution for this. So he asking me to find the general solution for non-homogeneous equation with non-constant coefficients. Let me explain again. My differential equation is non-homogeneous, and the coefficients here aren't constant. So you can't use the auxiliary technique. And because your differential equation now is non-homogeneous, so you need to use the hint, which is the substitution, such that the solution of your non-homogeneous equation is given to be y equal u times y1. Do you know that y1 is the given solution up? Because we agreed, I'm going to use this substitution, that such that the y1 is the solution for the homogeneous equation. Notice that this equation here, it's the homogeneous corresponding to this equation. So y1 is given up. So always I will give you the first solution. Any question before I continue? Any question? Let us continue. So now what I'm going to do is to write my y solution equal u times my y1, which I found it to be x. Now, as usual, if you need to use any substitution to solve a differential equation, you need to find y prime, y double prime, then plug it in your differential equation. So I'm going to choose Muhammad to help me now. Muhammad Tuhami. Muhammad Tuhami? Muhammad Tuhami here? Isn't here. So let me ask Marwan Umran.
Yes, doctor.
Yeah. So I have y equal u times x. Could you please help me to find u prime and u double prime?
Okay, it's going to be u
U
plus x u dash.
plus x u dash. Great. I wrote here the number 1 to let the students remember that I have a product. To find the differentiation of a product, I need to find the derivative of first times second plus first times derivative of second. Continue, please, to find the second derivative because your differential equation has second derivative.
Okay, it's u dash.
U dash, okay, plus
Plus u dash.
Plus u dash, okay,
plus x u double dash.
U double dash. Great. Now I'm going to take those and plug in my differential equation. Let me call it a star here. So star will give me, yes, continue please.
Okay, x power of 3.
Okay, times
multiply by the u double dash, which is u dash plus u dash, which is 2u dash.
So let me write 2u dash. Just 1 minute. 2u dash. What is it? 2u dash. Okay.
Plus x u double dash.
X u double dash. Okay.
Plus 3x square.
3x squared. Okay.
Multiply by u plus x u dash.
X u dash. Great.
Minus 3x ux.
Ux. Great. Equal 0. Now, only we need to simplify this equation. What do you think to simplify it?
I think we can multiply by, enter the x.
X cubed here and x squared. Yes, you are right. And also for me, can I divide by x squared. Those
Yes.
steps, look, those steps you are free. You can do them here after 3. So you can do what you want. It isn't necessary to do like what I'm going to do now, okay? So if I divide by x squared, so my equation, it will be here x, here 2u prime plus xu prime, double prime, I'm sorry, plus 3u plus xu prime minus 3u equals 0. Now I'm going to do, as you said, distribute the product here. So it will be the following: 2x u prime plus x squared u double prime, am I right? Plus 3u plus 3x u prime minus 3u. Can I simplify this equation more? Can I simplify it more?
The 3u will go with the negative 3u.
Yes, this, it will go out with this.
Doctor,
All right. Yes.
why it's equal to 0?
I'm so sorry. It isn't 0. It isn't 0 here. The right hand side, this one, let me use the red to know it isn't 0. It is x to the power 4. All right, Omar? So it is x to the power 4, not 2. And you divided it by x squared, so it will be x to the power. Thank you, Abdurrahman. Abdurrahman said,
Doctor, it wasn't me.
what's your name? Abdurrahman Najm?
No, it wasn't me, doctor.
It wasn't. Who said it is x to the power 4?
Abdullah.
Abdullah? Yes, great, Abdullah. So here it is x squared. Okay, any question here? All the steps are right? So let us continue now. Can I simplify more? What do you think?
2xu dash plus 3xu dash is 5xu dash.
So this term, it is similar to this term. So I have x squared u double prime plus 5x u prime equal x squared. Can I simplify more?
Divide by x.
Divide by x. If I divide by x, so I have the following. I have the following, x u double prime plus 5 u prime equal x. What about this equation now? No, Professor, it is non-homogeneous and non-constant coefficients. So actually, I feel I can't solve this new equation also. I use a new variable or new unknown function u, but unfortunately, I can't solve this equation now. By the way, I think no one of you asked me about the name of our method today. We call it reduction of order. And what I mean by reduction of order, I mean reducing the order. So I'm going to reduce the order of my differential equation from 2 into 1. Okay, notice now the given differential equation of order 2, and the new differential equation now also of order 2, because you have 2 primes. Our method has the name reduction of order. So reducing of the order of your differential equation. So I'm going to use a new substitution. Let u prime equal w. That will give me the u double prime is what? If your u prime is w, that means u double prime, it is what?
W prime.
Y prime? W prime.
W prime. Am I right? By using this substitution? Any mistake here? Don't forget, when you need to use the reduction of order to solve the homogeneous and non-homogeneous equation, you must use 2 substitutions. This is the first one, which will convert your y into u here. Then you will use this substitution, second substitution, to reduce the order of your differential equation. Let me write the following now. So, but give me 1 minute. So to solve number 2, I'm going to use first substitution to get the new equation here. Then this is the second substitution. So you have 2 substitutions. Now let me continue. X, instead of u double prime, you have w prime plus 5. Instead of u prime, you have w equal x. So now your new unknown function, it is w. You need to find w. If you find the w, you can go back to u, and if you find u, you can go back to y. Any question here? So if no questions, I'm going to ask you now, and 1 chocolate for who can help. How to solve this equation?
Maybe using the linear method.
The linear method. Who is speaking?
Marwan.
Yes, Marwan Umran. Yes, great, Marwan. This equation, it is first order. I'm right, because 1 prime. Linear, because I have only w and w prime. First order linear, so it is first order, as we said, first order linear differential equation. To deserve this chocolate, Marwan, you need to remind me the steps to solve the first order linear. Do you remember the steps?
I think so. Divide by x first to make.
Yes, so first of all, I'm going to divide by x. So this, I'm going to continue here. I'm sorry for my writing. So divide by x. So your equation, it will be, yes, w prime, continue please, plus.
Plus 5 over x w.
Great, equal
1.
1. Now to solve this equation as a first order linear, I'm going to use the green. This is your px, and this is your fx. First step,
I need to find the mu.
To find the mu. So mu fx equal, do you remember the rule? It is
e power of integration of p of x.
p of x, great, dx. So it is e to the integral. Where is your b? It is 5 over x dx. 5 over x, I'm sorry, dx. So this integral, it will be what?
هتبقى e power of 5 ln x.
So it is
e power of 5 ln x. So we'll simplify it. It will be x power of 5.
X to the power 5, great. Second step.
Substitute هتبقى mu of x في ال w.
Mu of x times w, great. Equal
integration of mu of x في ال f of
x dx. Am I right? Let us plug in. So instead of mu x, you found x to the power 5 times your w equal integral x to the power 5 times your f, which is 1 dx. Okay, so this is x to the power 6 divided 6. Am I right? Plus c. So your w, it is divide by x to the power 5. Am I right? Could you please help? So it will be
x over 6.
Continue.
Plus c over x power 5.
C to the divided x to the power 5. This is your w. But for me, I don't know w. I need y. So where should I go back?
I think the second one, which is u dash equals w. So
yes. So I'm going to clean those, the white. I think the blue, I don't need them. And I'm going to continue writing using the green up here. So just 1 minute. I don't need all those. So here I'm going up. Okay, here. So you told me that u prime, it is w. Am I right?
Yes.
So u prime
equals the integration of w.
Yes, u prime equal x divided 6 plus c over x to the power 5 Nothing here. So u equal integral of x divided 6 plus c divided x to the power 5 dx. So the u, it is integral of x divided 6, it is
x
x squared divided
6 times 2.
6 times 2, which is 12. Am I right? Plus, how to find the integral of c over x to the power 5?
C is a constant, so
C is a constant, so leave the c. How to find the integral 1 over x to the power 5? I forget this integral.
it will be x power of -5, so it will add 1, so 1 over x power 4, and
Yes.
down it will be 4. Yes,
Am I right like this?
yes.
Yeah, and you need to add a new constant for the integration. So this is my u. I don't know u. You used the u. I need the y. Where should I plug in now? Here. So my y equal the u. So this will give me here. It is x squared over 12 plus c over -4 x to the -4 plus c1 all times x, which is equal to, I'm going to write here, I'm sorry, equal x to the power 3 divided 12 plus c divided -4 x to the -3 plus c1x. This is the solution of the given non-homogeneous differential equation, this one. Notice now, your final answer has two constants and my differential equation of second order. So my solution is right. What do you think? Is it clear? Do you have any question? It is very important, and be sure you will find similar to this problem in your exam too and in your final. I'm going to summarize how to solve this problem using those substitutions. First of all, I will ask you to prove that one function is solution for homogeneous equation. Then I will ask you to find the general solution for non-homogeneous equation. So you have first solution. You will use this substitution. After some simplifications, you will get this equation, which also second order, non-constant coefficients, non-homogeneous. But notice here the idea of this differential equation, this one, no u, only the derivative of u's. So if you try to use this substitution and after some calculations, you get this equation, but in this equation also you have u with no derivatives, so you did something wrong. Always this equation, the new one, must be with the derivatives of u, with no u without the derivative at all. So after getting this equation, you need to use this substitution, second substitution. This substitution will reduce my differential equation from second order into first order, similar to this. I'm going to solve this as a first order linear, as you know, from the lectures in the previous week. And to solve the linear, you need those two steps. After that, you have to go back to your u, then to your y. Is it clear? So do you have any question? So let me do with you the worksheet, but before that, I need to ask one question. When we can use this rule, when we must use y2, when we can y2, this relation, can anyone explain when we use y2?
It's homogeneous.
If the equation is homogeneous, and he asked me to find second solution, that means he give me the first one. Okay, let me now share with you the worksheet and we can do it together. So the worksheet here, new share, and this is my worksheet today. I'm going to give you 3 minutes each one, but please, and if you want, you can share with your colleague. And by the way, I can break out the meeting into some rooms. I'm going to do that. Give me 1 minute now, just 1 minute. Could you please take a photo of the question? Or if you, or write the question down. I'm going to break out the meeting into some rooms so you can discuss with your colleague. Did you write it down? You have to practice.
Yes.
So I'm going to break the room, the meeting now. Just 1 minute. Don't leave the meeting. Into 5, I think, into 5, into 4, yes. 4, so it's 1 will be 3. So now we are going to check if we can do it together. I'm waiting the others to join again here. So Lubna and yes, 1 minute and we'll start. So this equation, it's homogeneous, but the difficulties for this problem, the difficulties of this problem is, all of you here, can you hear me now?
Yes, doctor.
Yeah. So now this differential equation is homogeneous. The difficulties that here I have non-constant coefficients. So I can't solve it using the auxiliary. And we agreed to solve the equation which has non-constant coefficients. I have to use the reduction of order. He gave me the first solution. So I'm going to find the second solution. I remember the rule of second solution, y2 equal y1 integral. My fraction here, denominator y1 squared, and the integral, it is exponential negative integral of my p dx dx. And here I have dx. First of all, I remember that my differential equation must has the coefficient of y double prime to be 1, so I'm going to divide by x squared. So I have y double prime minus 6 over x squared, y equals 0. Okay, where is my p, which I need to plug in here? Don't forget that your yp is the coefficients of y prime. No y prime, that means my px, it is 0. So now my y2, it is, where is my 1? y1, it is x cubed. So here x to the power integral e to the negative integral of 0 dx divided my x, my y1, it is x cubed all squared dx. So my y2, I'm going to write it here, equal x to the power 3 integral of 0 is what? The integral of 0 is what? Integral of 0.
Constant.
Yes, I can choose it to be constant, and my constant I can choose it to be 0. So you are free. You can choose your constant c or 0. Let me write it as c. So here e to the negative c divided x to the power 6 dx. So equal e to the negative c is a constant. So x cubed e to the negative c integral x to the negative 6 dx. So equal.
The integration is negative 1 over 5 x power 5.
You are right. So I'm going to add 1 and divide by the new. So it is negative 1 over 5, negative 1 over 5, or 1 over negative 5, 1 over negative 5, x to the power negative 5, plus the new constant c1. Plus the new constant c1. This is your y2. Okay. Now, well, students, Professor, you said that in y2, no need to add c, and here you did. No problem, as we agreed, because when you try to write the general solution, you will multiply by a constant, so don't care. For me, because I'm going to find y2, and y2 similar to y1. Those are particular solutions, so no need to write this c at all. And I'm going to choose my c here to be 0. So here I'm going to write e to the negative 0, which is 1. So now I have x to the power 3 times 1 over negative 5, x to the negative 5, which is x to the negative 2 divided negative 5. So this is particular solution. Professor, if I write in the exam plus c, and if I left here my c, this one as a c, not as a 0, don't worry, we'll take full mark. Because, yes.
يعني طب يعني x باور 3 اصلا ملتبلاي الانتجرال كله يعني المفروض كده
Yes.
x باور 3 c ف
It is x power 3 plus the c here. Yes, don't care about, no, I understand. So here you asking me why I choose this c. Yes, let me go back 1 minute. I understand you. So here plus the c, here I'm going to write it here 1 minute. So here equal and here plus c, c1. Am I right?
اقول براكت
and
يعني
here
قصدي
bracket.
انتجرال نفسه اقول براكت
Yes,
yes.
and sorry, the bracket after the e here. Am I right? Here. Yes. What is your problem now?
Now when I multiply x power 3 inside so
Yes, I choose my c's to be 0. It's a particular solution. It's a specific c. I need you to find any particular solution. If you need, no need to use this rule at all and guess the second solution. No problem for me if you can guess the second solution. And after that, you will write the general solution because he asked me. It is C1 times Y1 plus C2 times Y2. The idea here, you have to take care. If you need to guess, you must guess second solution Y2 if you don't need to use the rule, such that your Y1, which I give you, and the Y2, those are independent. You can't choose My y2, it is 2x3, because this is depend on this. Only you multiply it by 2. So I always advise my students, don't try to guess. Please use the rule to find the second solution. And if you find it's difficult to use those C's, choose your C's to be 0, because I need only one particular. If you choose your C to be 1 or C1 to be 2 or 3, you are right and you will take full mark. Okay, because it's a particular solution.
Yeah, doctor.
Okay, this is your question, because when you multiply by C1, this will be 0, so no need to write plus x to the power 3.
Thank you.
Okay, welcome. Other questions? So no need now to join at 1 o'clock because we finished the worksheet. Anyone of you have a question?
Yes, I have a quick question.
Yes, Lubna.
When do we use this method and when do we have to substitute?
Yes,
And
yes, I'm going to say. So, good question. So, Lubna said, Professor, you said that the reduction of order method, I can use it for two different cases. First case, I'm going to use the rule of y2 equal y1 integral and so on. And the second rule, y equal, the general solution, it is y equal u times y1. So in both cases, I have to give you y1, okay? This case used when you have only the homogeneous equation. And this substitution, you must use it when your differential equation with gx here, not zero. So this for non-homogeneous, and this for homogeneous. This is your question, Lubna?
yes, thank you.
Yeah, welcome. Other students? If no questions,
Doctor,
yes, Shannon.
when our breakout room solved this question, we didn't add the C except in the very last solution, which is C1 y1 plus.
When we try to solve this, the same here.
Oh yes.
And so we did what?
We didn't have a problem with the constant.
Yeah. So don't add the C. Don't add the C for y2. Y2, it is particular solution. So in y2, no constants, similar to y1, no constants. But the general solution, you must to multiply the first by constant and the second one by a constant. This is your question?
Okay. Oh yes.
Yeah. Great. Other students? So have a nice day. If no questions, please practice and practice and practice. Yes.
Thank you, doctor.
Welcome.
Thank you, doctor. Have a nice day.
Thank you. Bye bye, all of you. Bye bye.